In example 1, we have 3 plotted points of the 4 points of a parallelogram J, K, L, and M. We're asked to find the coordinates of point M so that this is a parallelogram. So I've gone ahead and plotted my points. Down here in the bottom is point J, here's K, and here's L. And now we want to find point M. There's actually a couple of different answers here, but what we're going to do is we're going to use the slope formula, or the idea of slope here, to verify that this is a parallelogram. Because remember, by a parallelogram's definition, opposite sides have opposite sides are parallel, therefore they have the same slope. Whew, that was tough to get out. So let's find the slope of K to L. To find the slope of K to L, remember slope is rise over run, I'm simply going to count on my grids. I'm going to count up 1, 2, 3, 4. So that's a rise of 4, and I'm going to run 1, 2, 3, 4 as well. So my slope of KL is a rise of 4 and a run of 4. Now I'm going to use that same idea of slope to count from J to find where the possible point for M might be. So I'm going to rise 1, 2, 3, 4 and run 1, 2, 3, 4. So right here is my possible point for M, and that's the coordinate 7 over and negative 4. So let's just go ahead and color this in here and make sure we have somewhat of a parallelogram, and it looks like we do. Looks like KL is parallel to JM, and that's what we should have if they have the same slope. Now, there's actually 2 other points on this coordinate plane that we could plot point M so that JKLM forms a parallelogram, but I'm going to leave that up to you. See if you can come up with at least one other point that forms that parallelogram. All right, in our next example, we're asked to verify that this is a parallelogram when the values for x is 10 and the value for y is 6.5. So if you notice here in our diagram, we have the angle measures for Q, R, and S. So let's find out what their measures are, and then we'll be able to tell if it's a parallelogram or not. So let's substitute the value in for y here for angle Q. When we do 6 times 6.5 plus 7, we're going to end up with 46 degrees. And now if we do angle R, we're going to substitute in our value for x. When we do 15 times 10 minus 16, we'll get 134 degrees. And then finally for angle S, when we do 8 times 6.5 minus 6, again we get 46 degrees. So you can see here what we have is angle Q is equal to 46 degrees, angle R was 134 degrees, and angle S is also 46. So we have one pair of opposite angles that are congruent, but we don't have both pairs. But what we do have is that angle R, which is 134, if we were to add that to angle S, we'd get 180 degrees. Same thing, if we take angle R and we add it to angle Q, we also get 180 degrees. So this is that theorem 6-3-4, I believe it is. If one angle is supplementary to both its consecutive angles, then it will be a parallelogram. All right, in our final example, we're asked to graph and show that quadrilateral JKLM is a parallelogram by using the conditions of theorem 6-3-1. And that says one pair of opposite sides are parallel and congruent. So we're going to have to use the slope formula and the distance formula. So I've gone ahead and I've plotted my points here for J, K, L, and M. Here's J and K, L, and M. Now let's go ahead and let's just use the segments JK and LM. So I'm going to go ahead and connect those guys, and I'm going to find the slope of KJ. So remember again, slope is rise over run. So because it's plotted on a coordinate plane, I'm just going to simply count 1, 2, 3, 4, 5. So my rise is -5, and I'm going to run 1, 2, 3. All right, now let's find the slope for L to M. Again, I'm going to come down 1, 2, 3, 4, 5. So my slope for LM is -5 as well, and I'm going to run 1, 2, 3. So far it's looking pretty good. I have one pair of opposite sides that are parallel because our slopes are congruent to each other. Now let's find the length of each one of these sides. So for the length of kj, I can use the distance formula, or I can think of this in terms of a right triangle, in which my Pythagorean theorem will come in handy, because the length of kj will just be the hypotenuse of the right triangle. It has sides 5 and 3, so I'll say 5 squared plus 3 squared equals c squared. So that's 25 plus 9, which is 34, is equal to c squared. So if I take the square root of 34, I'll end up with the length of that hypotenuse, and I'll just leave it as the square root of 34. And if I do the same thing for LM, I'll see that I'm going to form the same right triangle of sides 5 and 3. So I see that the length of KJ is actually equal to the length of LM. So I do have this condition 6-3-1, which says one pair of opposite sides are parallel and congruent.